When a tertiary or secondary alcohol is heated with a powerful acid such as sulfuric acid or phosphoric acid, an alkene is produced through a mechanism called the E1. Here is an example in which tertiary butyl alcohol is heated with sulfuric acid to produce 2-methylpropene and a molecule of water. While the reaction is not favoured enthalpically, it is favoured entropically, and the elevated temperature is used to increase the role of the entropic factor, while also allowing distillation of the lower boiling alkene product, thus driving the equilibrium to the right-hand side. Elimination from the alcohol to produce the alkene is known to be a stepwise process that begins with the protonation of the hydroxyl functionality to provide a better leaving group. This then breaks off to form an unstable carbocation. The intermediate then loses a proton from the beta position to produce the alkene product. Since the acid makes the reaction go faster and is consumed in the first step and regenerated in the last step, the mechanism is then catalytic in acid. Since the reaction is performed under strongly acidic conditions, the first step will be protonation of the weakly basic alcohol by the acid to give the protonated alkoxonium species. This step will be fast and reversible. The endothermic rate determining step follows, in which the water leaving group breaks away from the alkoxonium species to produce the tertiary carbocation. Since this slow step only involves the collapse of the protonated alcohol, it is therefore unimolecular. The unstable carbocation can then bond to a water nucleophile to go backwards, or lose a proton from the beta carbon, with the water solvent behaving as a base to give the alkene product. Higher temperatures favour the alkene formation and also allow for its isolation from the reaction mixture by distillation. In conclusion, when a tertiary or secondary alcohol reacts with a strong acid such as sulfuric or phosphoric acid at high temperatures, an alkene is produced. Overall, this is the loss of a molecule of water from the starter material to give the alkene. The reaction is known to be catalyzed by the acid and is described as the E1 process, in which the rate determining step is known to be unimolecular collapse of the alkoxonium intermediate to the carbocation.